Hello and welcome. In the next few minutes, I'd like to introduce the topics that we are covering in our lecture called Object-Oriented Software Construction. My name is Horst Lichter, and I'm the head of the Software Construction Research Group. This lecture is divided into two main parts. In the first part, we will introduce and discuss fundamental object-oriented modeling and programming concepts and approaches. We start with a basics chapter, followed by the introduction to reuse and reusability and design by contract. We then discuss the different views on inheritance, introduce different types of polymorphism and generics. Finally, we recapitulate the fundamentals and principles of software architecture design. In the second part, we focus on concrete software construction techniques. Here we start with a comprehensive look at use case modeling. We then introduce some techniques for modeling the problem domain, followed by an introduction to component-based software development. Next, we focus on the design and use of application frameworks before introducing some important and advanced design patterns. The last chapter introduces the concepts of code and design smells and corresponding refactoring approaches. Let us now take a brief look at all these chapters. In the Foundations chapter, we briefly introduce the different programming paradigms and give some background and historical information about object orientation. Finally, we present step by step all the elements of the so-called object meta model. Because reuse is an important goal in software development, we introduce this concept and present a taxonomy of reuse. We describe the process of developing reusable building blocks and briefly discuss existing software technologies. Finally, we present an approach to cost-benefit evaluation of reuse. Design by contract is a means to improve reusability and stability. Therefore, we introduce this specification approach and present some ways to implement design by contract in different programming languages. Next, we discuss contracts in the context of inheritance. Then we introduce defensive programming, which can be used to improve the robustness of reusable components. The next chapter is about inheritance. We present a comprehensive classification of the very different views on inheritance. Then we explain semantic relations that can be realized by inheritance, which finally lead to specialization, specification, and implementation inheritance. Polymorphism is covered in the next chapter. We explain the purpose of polymorphism in programming and present a comprehensive overview of polymorphism. Since genericity is a form of polymorphism offered by many programming languages, we will discuss it in more detail and explain the different types of genericity. The last chapter of the first part is devoted to software design and its basics. We introduce step by step all important design concepts and discuss their interrelationships. In addition, we introduce some important design principles and discuss properties of good designs and software architectures. The second part of the lecture begins with a discussion of use case modeling for specifying functional requirements. We present different approaches to specifying the behavior captured in a use case. Next, the steps of a systematic use case development process are presented before discussing guidelines for writing use cases and discussing anti-patterns in use case modeling. Then we focus on application domain modeling. We introduce the basic terminology and present a simple language-based approach for identifying important domain concepts. We also introduce domain-driven design, a technique to structure complex domain into manageable and reusable subdomains and to define their dependencies. Component-based development is the next topic. We introduce this paradigm and present basic properties of components as well as the general concepts of all component models. As an example, we briefly introduce the OSGI component model. After discussion of modularity in Java, we introduce the basic OSGI concepts and in particular present the states of the life cycle of OSGI components called bundles. Finally, we are talking about managed components. These are components whose life cycle is not controlled by the programmer. We explain important mechanisms such as inversion of control, dependency inversion, and injection. We use Spring and JEE as examples. Application frameworks are reusable in a specific domain. We discuss class libraries in comparison to frameworks, explain the difference between open and closed frameworks, and introduce the concepts of variability and extensibility in the context of framework instantiation. Finally, we present an approach for developing application frameworks based on the defined hotspots. Next, we turn to the topic of design patterns. We start by discussing some selected basic design patterns introduced by the Gang of Four. We then introduce some enterprise architecture patterns, such as the service pattern or the Fluent API pattern. Finally, we introduce some architecture patterns, such as MVC and microservices. The last two topics covered in this lecture are refactoring and bad smells. First, we define refactoring in the context of software re-engineering. We introduce the steps of a general refactoring process and show some commonly used examples of refactorings. Then we introduce the concepts of code and design smells in object-oriented programs. Finally, we present approaches to detect bad smells using software metrics.